My name is Olivia Bunce, and today we'll be learning about the law of superposition. The objective of today's video is to demonstrate how the law of superposition remains relevant in today's modern archaeology and how it's used in the geology field. Furthermore, we'll learn the major principles of stratigraphy and how they relate to superposition. The origins of superposition date back to 1669, when Nicholas Steno made the correlation of fossil shark teeth being inside a rock. Because the fossil was much older than the surrounding rock, they built upon the idea that geological formations can be dated by the fossils they contain. Steno then formulated the law of superposition, stating that in any sequence of undisturbed sedimentary rocks, each bed is older than the layers above it and younger than the layers below it. His rule became the most fundamental principle to relative dating. How do geologists use this law? Well, in early dating techniques, geologists use this principle to organize rock layers and artifacts based on their positions and to infer their relative ages. How is it a tool, you might ask? Understanding a site's stratigraphy gives someone the context to determine what artifact types or styles were older than other forms in particular sites. With it, we can fill in more of a site's geologic history. What is its impact? It builds the geologic record, which is fundamental to geologists' work in organizing the history of our planet. For geologists, the law of superposition presupposes the existence of decipherable geological sections, and every section must have a top and a base. Here I've outlined 3 related principles of stratigraphy, which will help us understand the law of superposition. The first is original horizontality. Sedimentary rocks are deposited originally in flat horizontal layers. The next is lateral continuity. Layers are continuous that may be removed by erosion after their deposition. The third is superposition, which we should know a little bit about already. Sedimentary layers give relative age older or younger than the layers above or below. So now we get into my related example, the Grand Canyon using the law of superposition. Did you know that the area in the middle of Arizona was once a sea? Layers of the Grand Canyon give us information on fossils found from the ocean. On this slide, I've colored layers of the Grand Canyon to give you a more visual example of the youngest to oldest layers. Starting with the youngest, layer C in yellow is Paleozoic strata, which contains fossils like small sea creatures and hints to a warmer, shallow sea when sediments were deposited. The pink layer, B, is the Grand Canyon supergroup, or the Middle and Late Proterozoic. Not many fossils tells us that it was deposited before complex life was common. X and Y, which is sandwiched between the yellow and the orange, shows unconformable contact gaps in the geological record. Sediment and rocks eroded before new material was deposited. And finally, the oldest layer, A, in the darker orange, is the metamorphic basement complex. Metamorphic rocks with igneous intrusions tells us that volcanic islands collided with landmass, forming rocks through heat and pressure. So how is the law of superposition still relevant today despite its old age? Well, for one, it's used in archaeological research to this day. It's a necessary logic and framework for ordering geological events, and alongside other methods, one being radiometric dating, can be used to place and order events on the geological timescale. The Harris matrix is also another example of it being used today. It's a commonly used way of categorizing findings while building upon the law of superposition's methods. It involves diagramming materials above and below layers to understand succession and approximate dates. It's a simple concept that continues to help our archaeological studies for both long-time researchers and new students. Thank you for watching my video, and I hope you learned something.